So the first question that I'm going to go over for the practice test for Unit 3 is question 1. They gave us this graph and told us that this is the graph of f of x. So part A for this question says you need to find where f prime of x is equal to 0. Now we know that the derivative is equal to 0 when the slope of the tangent on this graph is equal to 0 or is horizontal. So I can clearly see that this graph has horizontal tangents at this point and at this point. So B or C, and C, would give you full marks there. Now, if you wrote x equals B and x equals C, it didn't mark it right, and I would have to go back and give you the marks, but that is the correct answer. The next thing that it was asking you for is when f prime of x is greater than 0. So what I like to do is take my pencil or pen or whatever I'm using, and I like to just draw little lines or even picture little lines to help me visualize what's going on. So I'm just going to use yellow, I guess. So if I'm following this graph, I can clearly see that if I were to draw a whole bunch of tangents, they would be positive or increasing here. At point B was where it went horizontal, and then at this point, as we rounded this mountain or bend, they turned negative until they went horizontal again and then turn positive again. So if I'm trying to write my answer for when my derivative is greater than 0, I'm going to have that x is between A and B, and then it happens again when x is between C and D. Now for part C, it asks when the derivative is less than 0. I'm just going to change colors so that it's a little bit easier to see because it's getting pretty messy here. And I already talked about how that happens in this section of the graph. So when x is between B and C. Okay, so question 2 says, using the function f of x is equal to x cubed to find each of the following. So A says the value of x where the slope of the tangent is 27. Now if you wanted to, you could use your first derivatives principle and you could calculate the derivative. If not, you could just recognize that you could use the patterns that you found in the last week, or the last section, I guess. And so we could see, sorry, I don't know what's going on with my pen here. We could see that the derivative of f of x is equal to, you're going to bring your power down and reduce the exponent by 1, so 3x squared. So if I'm talking about part A here, it says the value of x where the slope of the tangent is equal to 27. So what I can actually do is I can plug a 27 in for f prime of x is equal to 3x squared. I can divide both sides by 3. I'm going to get 9 is equal to x squared. And remember, when I take this square root, I need to make sure that I'm putting a plus minus in front. And so I'm going to be able to get x is equal to 3 or negative 3. Part B says the slope of the tangent when x is equal to negative 5. So again, I'm going to have f prime of x is equal to 3x squared, so just writing my equation in there. I'm saying f prime of negative 5 now, so 3 times negative 5 squared, so 3 times 25, which gives me 75. Now, because I did A and B, C and D are probably going to seem a lot easier for you. So C says the value of x when the slope of the tangent is 3. So 3 is equal to 3x squared. Divide both sides by 3, and you're getting x squared is equal to 1. Take the square root. Don't forget your plus minus. and you get x is equal to 1 or negative 1. And then for part D, it says the slope of the tangent when x is equal to 2. So f prime of 2 is equal to 3 times 2 squared, which is equal to 3 times 4, which is equal to 12. Question 3 says, it is known that the displacement of a particular object is given by the equation s of t is equal to 2t squared plus 5. Then at time, it says a, t is equal to 2, the velocity is. So before we can start, we do need to talk about what our velocity function will look like or will be. Now we know that, the derivative of our displacement function, so s prime of t, is equal to our velocity. So we are going to have s prime of t is equal to the derivative of our function up here. So again, you could use your first principles or you could use the rules that you found. You have a coefficient of 2 times an exponent of 2. That will give me 4. T, instead of squared, it's going to be to the exponent 1 because we are lowering it by 1. And then the coefficient plus 5 is going away. So for part A, I'm trying to find the t equals 2, or the velocity at a time of 2. So s prime of 2 is equal to 4 times 2, which is equal to 8. For B, I want to find the velocity when time is 5. So s prime of 5 is equal to 4 times 5, so 20. And then C says when the time is 2.5. So s prime of 2.5 is equal to 4 times 2.5, which is equal to 10. For question 4, we have to use the function f of x is equal to x cubed minus 4x and find the average rate of change between x equals 3 and x equals 4. So if you remember, we do know that for average rate of change, we are using that formula f of 4 minus f of 3 divided by 4 subtract 3. So if I were to do f of 4, I'm using my original function, not my derivative. I'm going to get 4 cubed minus 4 times 4. So I'm plugging a 4 in everywhere I see an x. So 64 minus 16, 48. And then just off to the side again, f of 3, 3 cubed minus 4 times 3, 27 minus 12, 15. So I'm going to be getting 48 subtract 15 divided by 1. So 33 divided by 1, so 33. I'm not going to solve for b, but you would do it the exact same way. So you would be saying f of 0.5 subtract f of 0 divided by 0.5, take away 0. For question 5, it is basically the exact same as question 4, except now we're trying to find the simplified average rate of change between x equals 2 and x equals 2 plus h. So I will show you the full solution. We are going to be using the exact same formula. So average rate of change is equal to f of 2 plus h subtract f of 2 divided by 2 plus h subtract 2. You will have to pause the video to see the full solution, but I will do it right now. So as you can see, I've done f of 2 plus h subtract f of 2 divided by h. I FOILed out this first bracket to get this simplified and got a final answer of 4 plus h. For part B, you will be doing the exact same thing, except you will be using the new function f of x is equal to 1 over x. When that is all said and done, you will be getting an answer of negative 1 over 4 plus 2h. For question 6, we do have a couple of options. The first option would be to multiply this through. So we are going to be doing f of a plus h. Subtract my f of a. Divided by h. I would FOIL this a plus h out. A squared plus 2ah plus h squared plus 5. And I would bring this negative through. All divided by h. So 2a squared, we're going to bring this 2 through to each term, plus 4ah plus 2h squared. This plus 5 and this minus 5 cancel each other out. Minus a 2a squared divided by 8. We've got a few more terms that cancel each other out. I'm going to factor out an h and be left with 4a plus 2h. And my final answer is going to be 4a plus 2h. At this point in time, I can plug in my a of 1 and my h of 0.1. And I would get 4.2. The second option would be to plug in our a of 1 and our h of 0.1 right in the beginning before we plugged those values into the functions, and it would result in the same answer either way.